Miller Mahdeev with 8451 here. Welcome to another episode of The Uplow'd. We're glad you're here. Each month we dig into the world of AI, thick data, machine learning, data science. We invite you to stick around and let us know what you think. Keep an open mind and stay curious.
Welcome to The Uplow'd by 8451. I'm your host, Dan O'Keefe, and on this episode we're talking to data scientist Greg Anderson about spatial analysis. Welcome to The Uplow'd, Greg.
Thank you very much.
So do you want to be talking about the quantum realm and like how that saved the world or anything like that?
If you'd like, I guess we can get into that, but maybe we should start pretty simple.
Let's start small. So, Greg, spatial analysis is a new topic for our podcast. We've not touched it before. How did you come to be a data scientist with a focus on spatial analysis?
That's a good question. Actually, my experience kind of goes across multiple disciplines. My formal education is in what's called geospatial information technology, which kind of blends this idea of using statistics and computer science with a third component of GIS, which is geographic information systems. So basically that's just maps and spatial data. My experience has kind of gone from everywhere from can we model the incident rates of diseases in animals across the Great Lakes to correcting satellite imagery because of cirrus cloud interruption to now how do we model consumers across the market and how are they going to different retailers?
Okay, so can you expand even more on what is spatial analysis and how does it relate to the everyday Joe?
That's a great question. So in its most simplest form, spatial analysis is just analysis with spatial data. And when we're talking about that, we're talking about points, lines, and polygons. For example, with spatial points, we're talking about like the centroid of Cincinnati or the centroid of Louisville. And they have a spatial topology, which means that their distance between each other makes a difference, or we can actually measure the distance.
What's the centroid of Cincinnati versus the centroid?
I would imagine when I say centroid, it means like the center.
Okay.
So with the city, we can think of it as a polygon, so it's got boundaries, but then we can also think of it as a point in space. So it's how we usually visualize it on a map. Like Atlanta might have a star because it's the capital of Georgia, right? But in reality, Atlanta is much bigger than just that star. It actually has boundaries to it that make a difference politically.
Okay.
So with the three different types of spatial data, we're talking about those points. I covered the other one, which is polygons, and then we have this third called lines. And a good example of using multiple of these is when you use your smartphone to basically find what's the closest gas station with a car wash, for example. That is a spatial query, but we've actually added an additional feature in this, which is tabular kind of information. So you've asked me, to find the closest gas station that has a car wash. So that's an attribute. So in terms of a spatial analysis, I'm first filtering out all gas stations that don't have a car wash.
Okay.
Then we have to think about it in terms of where you are. You have an origin, a location that you exist, and then all these gas stations are basically destinations. So now we need to kind of represent what is the cost of you as an individual traveling from your location to the destination along a road network, which are the lines. Each one of those lines that exists within a road network might have different attributes. For example, it might have direction. It might be a one-way street, or it might have something like miles per hour, the speed limit. That is, I can't travel over 40 miles per hour here. Or it might have traffic, or we might want to limit the number of left-hand turns. So all of that might go into this simple query that you've made to your smartphone that says, find me the gas station that's closest that has a car wash. But not only that, we probably are going to find not the first, but the second and the third, and make you have the choice.
Huh. So spatial analysis is new to data science, or?
So that's a really great question. It actually dates back to the 1800s. The first spatial analysis, they say, was done by a physician in London named John Snow. And it actually...
The John Snow.
The John Snow. Not the John Snow that you probably know, but John Snow, the physician who actually is attributed to also, I think, expanding upon the germ theory. This actually happened prior to acceptance of germ theory. So at the time they thought diseases like cholera actually happened through bad air or pollution, which so you just didn't want to walk in certain areas of the city. And what John Snow didn't accept this as fact. And so what he actually did was survey a bunch of individuals, and he found that the individuals were actually clustered around one water well within London, that there was a high incident rate of cholera around this one pump. And so he, with this a map and simple statistics, was able to demonstrate that there was a high probability that this water well was contributing to cholera. And the waterworks services found out that he was correct, that one baby evidently had cholera and it got into its diaper and then went into the well. But this actually was a pretty groundbreaking point in our history, because I don't think until then there had been this relationship between a source and something like cholera. And it changed the idea of how we treat water, not only within London, but worldwide, and definitely has increased the health worldwide because of it.
That's great.
There's some other pretty neat examples.
I think people have gotten rich using, or helped other people get rich using spatial analysis,
right? So there's an example from South Africa in the 1950s and 1960s. It's actually a really important one if you track the history of spatial analysis, because this one actually demonstrates the use of statistics and spatial analysis melded into a model for the first time. In the past, we might use things might vary over space, but we just assume that there's a kind of a constant rate of decay. The question is, can we actually model that decay? Meaning, things are more similar as they get close to each other, but as you get farther apart, their influence might change. And Danny Craig was actually a mining engineer, and he was evidently pretty good at statistics. And what he observed is that when they were mining for gold, that there was a higher chance of getting gold when there was a survey nearby that also had found gold. Seems pretty simple, but what that idea is pretty groundbreaking. It's pretty similar to the idea of time series analysis. And a good example of this is we might use time series analysis with stock prices. So I might predict the stock price of a certain stock today based off of its price yesterday and the day before and the day before.
Right.
Because it not only gives us kind of a ballpark, but also gives us an idea of trending. With spatial analysis, we're actually doing that with 3 dimensions. Time series is only a single dimension. So what Danny Craig found is that the probability of gold being a location can be a function of all the areas around it. So if I've done surveys surrounding this area, I could have a high likelihood of, or a good probability, a good chance of predicting how if there's going to be gold in that location or not.
Okay. Can we take any of this to Vegas and put it to work? No?
Probably not.
All right. Okay. Well, thank you for that. And one topic that we do touch on often on this podcast is machine learning.
Sure.
So how does machine learning play into spatial analysis?
Well, that's great question. So spatial analysis in itself is pretty rich and vast, and there's lots of things that we can do with it alone. We can do a lot of things with machine learning alone. But just like how machine learning basically creates a unique tool sets, by adding in spatial analysis, we're even getting a more unique tool set to solve more unique problems. For example, one thing that we might want to do is estimate the amount of demand for a certain product across a city. So that has spatial information and also tabular information that might incorporate into a model. Essentially, when we're dealing with spatial analysis and with machine learning, we're trying to capture 2 different types of spatial attributes. One is this idea of network effects. So, for example, if I were to alter a network, and a good example of this might be, let's say we have a city that has multiple fire stations that exist across that city. And the city is realizing basically that there's high incident rates of houses burning down because there's just not enough fire stations. So they want to know what's the best place for them to put this fire station. So one way to think of it is that each fire station basically has its own catchment or service area that it can service or to fight fires within. If we were to actually add another fire station there, we might have overlap of those service areas, but in doing so, it actually kind of reduces the demand or requirements of those other fire stations. So if they have too much load, they might want this third fire station to exist within the city. So with machine learning and spatial analysis, basically we can quantify what is the impact of you adding that third fire station. So is it reduce the rate of the load of the fire stations, and in turn, will it decrease the probability of a house burning down or not being able to service something that was needed for the fire station to have performed?
Great. I appreciate that explanation. It's amazing stuff. So how does 8451 use spatial analysis, and what insights can that provide for other retailers?
So there's a variety of ways that we use spatial analysis. Primarily, it's just to get better insights about our customers. While we have information about demographics of the people that are shopping in our stores, we don't have demographic information about those people that are not. Sometimes we do through the National Consumer Panel, but our stores exist in space. They are actually points that I could put on a map and tell you how to travel them to.
Right.
So that being the case, our customers also exist in space, and so do those people that don't shop at Kroger or any affiliated store by Kroger.
Okay.
And so we can first identify, demographics that we might not be actually getting to the store, but exist within our trade area. So kind of targeting either assortment or format, or kind of customizing the store towards those demographics that we're missing. Another way that we use spatial analysis and machine learning is to basically predict demand. So in this case, we are often interested in dealing with this other spatial attribute called spatial autocorrelation, which is that things that are close by each other are going to be more alike. So the idea here is that you're probably more like your neighbor than you know. And
you haven't seen my neighbors, but
yeah, maybe not. But you probably live in the neighborhood that you do for a reason, and so often like demographic variables are spatially structured, and so we want to capture both space and those demographics in our predictions of models. So in the case of demand, we're trying to incorporate the fact that we might know demand in one area because we have a Kroger store. But we want a model to basically predict how that demand would be in other areas where there's not a Kroger store, but it might have similar demographics. And we might have clues into how well that demand or how much demand is in there just through kind of spatial analysis.
Right.
So the idea that things are more similar as they get close.
Okay. Well, thank you. And so how can you affect the decision-making process for instance, an Ocado hub or spoke versus a brick and mortar location?
Well, that's a great question. It's something that I've worked on more recently. We have, just like I was saying, we're estimating demand. We can actually estimate demand not only for just total grocery, but rather also by channel. So what's the likelihood that you would buy a certain product in through an online mechanism or through a brick and mortar format? And so understanding demand at that more granular level, at a channel level, allows us to have more strategic decisions about where do we place, omni-channel platforms. Because not only are we focusing on, omni-channel platforms that will solve for grocery problems, but we want to know at a product level, are you more likely to buy something through e-commerce mechanisms or through a brick and mortar format? So we want to make sure that we are fulfilling your groceries the way that you want them to be. And so that all originates through this idea of understanding demand, which is a spatial analysis function.
Great. And I should have mentioned, Kroger recently announced its partnership with Ocado. So what's another good example of how your work has affected or will affect the rollout of that partnership overall? As I was mentioning that we were estimating demand, that demand by channel is actually utilized to prioritize not only what markets should be rolled out Ocado into first, but where should those Ocado fulfillment centers be. The way it works is that Ocado it works on this kind of hub and spoke mechanism where you have these large fulfillment centers that then products are then put out to spokes, which are basically smaller areas that then are put onto vans that will eventually go to the consumer, whoever ordered the product. And so we want to be able to optimize where those hubs and spokes are located so that they can service the people that are more likely to be purchasing groceries through e-commerce platforms versus those individuals that probably want that experiential quality of being in a store. Gotcha.
So by understanding demand by channel, we're able to do that. We're able to customize that kind of fulfillment process to fit the customer.
That's great. And bring it back to Kroger for a second. What about existing Kroger stores? What sort of insights can you apply to them using spatial analysis and machine learning?
That's a great question. I have, that's probably the majority of my work is focused on that. There's 3 ways that we impact the current Kroger network. Basically, we want to know if there's areas where there is more demand than supply, and there's a couple actions that we can do there. We could add a store to that network,
we could expand a store or acquire a new store, meaning like there was a competitor that might not be doing really well and that's smaller that doesn't want to maintain the grocery business anymore.
Okay.
So we might purchase that. And the kind of other side of the coin, we have an area where there's too much supply and not enough demand. And so we might want to kind of customize our store to that situation, either by reducing its size, changing its format, or maybe trying to fulfill those customer orders through some other channel.
All right, so for consumers, that's a reason, or those are components as to why they walk in one day and see that it's been remodeled or expanded or...
Well, that kind of brings up the third point, which is that we might have a store that's underperforming, but the demand's high. And so that's the case that we might not have a store that's perfectly tailored to its customer base.
Okay.
And so that we might either remodel, might be an older store, or might have to increase its services. Like, for example, you might want to go to a store that has a coffee shop so you can drink coffee in it. So we can actually change our store if that's a really important attribute for the customer base, such that it would have that coffee shop.
That's great. And again, that's all driven by spatial analysis.
It is, yeah.
Okay. And then what will your work impact in the future for Kroger?
So I'm currently wrapping up on a project that will probably impact every large Kroger project, meaning like building new stores, acquisitions, potentially remodels, expansions, and then relocations. All that goes through kind of an automated process that scores about how we expect that store to perform or that project to perform, given demand, different attributes, its different competitors, the cost of travel for the consumer base to the actual store, attributes of the store, and then also what's the potential for any kind of sister store cannibalization. Are we putting stores that are too close to each other? So all this kind of allows us to optimize our Kroger network such that we're maintaining high volumes and also serving our customer base perfectly to the way they want.
And you're working on this now?
I'm working on this now, yeah.
So you're leaving us with a cliffhanger here.
Yeah.
Okay.
Well, we're at the tail end of this project. We finished our proof of concept. And what we actually found is that, while machine learning and spatial analysis is giving us more precise estimates and a quicker fashion, what we realized is that incorporating information about the domain experience, so like the people that, Kroger has a long history of putting in stores across the United States. They have a lot of stores. They're pretty good at it. We're pretty good at it with a machine learning model, but we go at it a whole different way. By incorporating both of these approaches into our selection process, we end up getting the best estimates and the best store locations possible.
That's great. All right. Well, it's nice to understand more granularly exactly how all that works, right?
Yep.
What affects our local Kroger stores. And now it's time for the 8451 lightning round, Greg, where we ask you a series of 8 random questions for 51 seconds.
Okay.
Greg, are you ready?
I am most definitely ready.
All right, here we go. What one item do you buy every time you go to Kroger?
I have 2 kids. I always buy milk.
Okay. At what age did you first feel like an adult?
I would say when I had my first kid, the first night in the hospital, he stayed up all night long. I was an adult at that point.
That was a lesson, right? What was your first memory of being really excited?
I would say probably Christmas time when I was 5 or so. I have 2 older siblings that are 5 and 7 years older than me, and I can remember playing vinyl records and dancing around, and that was a really good point in my life I look back to.
Awesome. And then what is the longest distance you've ever traveled on foot?
2,176 miles. I actually hiked the Appalachian Trail when I finished college.
Very cool. Would you rather have unlimited access or unlimited tacos for life or pizza for life?
Assuming both are high quality, tacos and pizza, I would say pizza.
All right.
I've just got into making pizza. Love it.
What is the last book you read?
I actually read a lot of machine learning books. So the last book I read was probably Deep Learning with Python.
Okay. Yeah, I read that one too.
Yeah, of course.
Who is your favorite movie director?
Wes Anderson.
And what in your life has taken the most courage to accomplish?
I would say my career, I've kind of spanned multiple disciplines, and each time I jump to a different discipline, it's been difficult and takes a lot of courage to say, I want to go into something completely new that I know nothing about, but I want to carry my skill set over there. It ends up being really impactful, but it's scary.
Awesome. Well, thank you, Greg, for being our guest today. I'm your host, Dan O'Keefe, And by the way, I'm being told that we did not make the lightning round 51 seconds. That's okay. You did a great job anyway. Thank you, Greg. I'm your host, Dan O'Keefe, and we will see you next time on The Upload.
Millen here. That's it for this month's episode of The Upload. We hope you enjoyed it and hopefully learned something new. Remember to give us a like and share your feedback. Until next month, stay curious.